Good morning all. I am Sunil, working in Kendriya Vidyalaya, No.1 Mangaluru. So today I am going to give a lecture on problem solving techniques using algorithm and flowchart in computers. So you may be familiar with the different types of problems. Okay, normally computers are using to solve formal types of problems. That means there are two types of problems. One is formal and informals. Formal problems normally we are handling with the help of computers because there we can apply algorithms, right? There may be clear-cut methods to solve the problems. So before solving a problem, what is the very important thing? You have to analyze the problem. Problem analyzing is very important part of the problem solving techniques. So after analyzing the problem, we may be able to understand the problem. We may come to know the objective of the problem, the aim of the problem. Once we are getting about the clarity of the problem, we may be able to write the inputs needed for the problem. What are the inputs needed for the problem? So after getting the inputs, then we have to think about the outputs needed for the problem. What are the outputs needed to generate from the inputs? So once we are identifying the outputs, now the transformation has to be happened. That means how the input has to be converted into output. Okay, that process logic we are calling it as algorithm, right? So before applying algorithm, we have to know the inputs and outputs, right? So that is generally we are calling it as software requirement specifications, SRS specifications. Specification means once we are getting the problem, we should be able to analyze the problem. After analyzing the problem, we should be able to understand the problem. We should be able to write the objective of the problem. So after completing the objective of the problem, we should be able to write the inputs needed for the problem that we are representing with the help of variables. Then we are writing the outputs. What are the outputs needed to generate from the problem? So that also we are output variables we are representing with the help of variables. So then we have to convert that input into output. That we are calling it as process logic, right? So whenever you are handling complex problems, how to tackle complex problem? That complex problem we have to decompose into smaller number of modules, small algorithms we have to make. So each modules we have to find out the algorithm, and afterwards all the algorithms in individual modules we have to integrate and finding the solution of complex problems. So how we are decomposing the complex problem into individual modules, that we are generally using structure charts. Alright. So now here what is the main discussion? How to design a good algorithm. So when we are thinking about an algorithm, always algorithm means it is a logical sequence of well-defined steps. Logical sequence of well-defined steps to reach the solution of the problem. So always an algorithm have the following properties. It should be independent of the programming language, right? That we can see, and it can be and this algorithm afterwards we may be able to implement in different programming language. And always an algorithm should have a starting point as well as an ending point, right? So two things we have to be considered while designing the algorithm. One is time complexity, and second one is space complexity. Time complexity and space complexity, it indicates that an efficient algorithm will take less time as well as less space. Memory, it will take less number of variables, less space it will take. It will be handling the problem with minimum number of variables. It may take less space, memory space. It may execute fast. Okay, so faster the algorithm, that algorithm always will be more efficient. So it will be executing in very less number of steps. Okay, shorter time. So it is inversely proportional to the computer's clock speed. Right. Now we'll see some of the algorithms, how we can handle different types of problems. Okay, with the help of algorithms we will handle it. So first one is how we can write an algorithm to put a book into the box. Just see, first step 1 is start, step 2 is pick the book, step 3 is put the book into the box, right, inside the box, then close the box, and that is the algorithm for this particular problem. You just see second algorithm. It is for finding the sum of two numbers. You start the algorithm, okay, start, then to get two numbers n1 and n2, then you just see sum is a variable, and n1 and n2 we are summing and storing in sum. Then we are step 4 is printing that sum, then fifth is end. Always we can see algorithm, in the algorithm or both algorithm we can see a start point and end point, and always it is reaching to the end point from the start point. All the sequence are executing one after another. This all the steps are sequential, right? Both the problems. Now we can see a different variety of problem. Problem 3. Here all the steps are not executing. Based on the conditions, some steps are not working, some steps are executing. That is selection statement, right? Earlier one is sequence statements. See the voters eligibility, okay? How they are eligible for voting. So reading the age, checking age is greater than or equal to 18. Yes means we are going to step 4. That means voter is eligible for voting. Afterwards, we are just directly going to step 6. That means step 5 is omitting. It is not executing. The same way, if a voter's age is lesser than 18 means directly it is going to step 5. That means step 4 is omitting. It is exempting, okay, from execution. So after printing step 5, it is going to step 6. That means some part of the instructions are not working, some part of the instructions are working. That is purely based on the conditions, right? So that is we are calling it a selection statement, right? Now we can see the fourth problem. That is as a group of statements in a problem are working a certain number of times. That generally we are calling it as looping operations, right? Iterations. Just see how to find the sum of four numbers. First we are starting sum initializing with 0, count is initializing with 0. We are reading the first number, that is read n. Then that value is adding in sum, right? Accumulating. Then counter, one number is already over, count is incremented by 1, right? Count is 1. Now checking counter is reached to 4. No, it is lesser than 4. Then what we have to do? We have to start repeat step 4 onwards. Repeat 4 means read n. That means we are reading the second number. That second number again in step 5 it is adding with sum, right? Count is incrementing by 1. That is count is 2. Again it is lesser than 4. Yes. Again what is happening? Again it is going to step 4. It is reading the third number. Again that third number is adding with the previous two sums. Count is now 3. Now again lesser than 4. It is step 4. That means it is reading the fourth number. Again that fourth number is adding with the previous three numbers. Count is reaching to 4. Right? Now it is lesser than or equal, lesser than 4? No, it is 4. So automatically it will go to step 8. What is step 8? Printing the sum. That means a group of statements from 4 to 7 are working 4 times, a certain number of times. That is what is called as looping operations. So with the help of computers, we can do the repetitions quickly, right? We don't need to manually do again and again, right? That is the advantage of looping operations. See, we are just concluding the earlier one. There are the previous 4 algorithms. We can conclude that in algorithm there are 3 ways. Algorithms comes under 3 ways. One is sequence. We have discussed problem 1 and 2. Selection, problem 3, because some statements are not working, some statements are working. Sequence means all instructions are working from start to end, right? No statements are exempting. Iteration, we already discussed problem 4, finding the sum of 4 numbers. So a repetition of statements, that is looping operations, right? Now we'll come to the flowchart. What is flowchart means? The pictorial representation of algorithm. We know picture is always more effective than words. So flowchart, that is the advantage of flowchart over algorithm. So you can represent the problem very easily with the help of flowchart, and others can easily understand the thing. Okay, but we cannot directly, a layman cannot draw the flowchart directly. First he has to write the algorithm. Then from the algorithm he has to draw the flowchart by using different flowcharting symbols, right? So these are the different flowcharting symbols. One is start and stop, that is oval shape. Process symbol is rectangle. Decision making is rhombus. Okay. Then input output symbol is parallelogram. Connector is circle. Connector means suppose you have a problem, you are unable to represent in one page. It has to go to next page. So both the pages we should connect. That is with the help of circle. Circle with label with L. Inside the circle we will label it, and that label we will carry it to the next page. Right. Flow line means every symbol should be connected. So after step 1, step 2, after step 2, step 3, like that means we are connecting all the symbols with the help of arrow keys. Either it may be down arrow, up arrow, left arrow, right arrow, based on the sequence. Okay, sometimes selection, up, looping operations and all. You have to use different types of flow lines. That we can see it in coming problems. Okay. Now we'll see different how we can see different examples to draw the flowcharts. So it's the same problem we are representing with the help of flowchart. How to find the sum of two numbers, right? So start oval shape, input number 1 and number 2, that is represented with the help of parallelogram. So rectangle we can see process sum is equal to num1 plus num2, and parallelograms we are printing the sum, then end. So all the statements are mandatory. So you can see the flow lines from start to end, down arrow. Okay, down arrow you can see, or everywhere down arrow is there. Right. Now we just see the biggest among three numbers, right? So just see the flowchart of biggest among three numbers. Start in oval shape, read ABC, parallelogram, is A greater than B, right? So flow line we can see one right arrow, left arrow in the decision box. So if the condition is A is greater than B means yes means again A is checking with the C. Again A is greater means again you can see yes, A is the greatest. You can see printed. If no means C is the greatest. So there we can see here it is C. Here it is C. If A is greater than B, if it is false means it is coming here. B greater than C. If it is true means B is the biggest. Otherwise no means B is the largest number. So all everywhere you can see flow lines here. So all reaches to the stop point. So wherever you goes, wherever the flow problems travels, the sequence moves, it has to come to the end point. So from start to end, it has to reach, right? Now the flowchart thing for a looping operations. How to find the factorial of a number? Just see. Start, read the number, I is equal to 1, fact is equal to 1, that is in rectangle. So we are checking I is lesser than or equal to n. So first, for example, I want to find the factorial of 3. So n is 3. So I is 1 here, I less than or equal to 3? Yes, I is lesser than 3. So automatically it is 2, I is I plus 1, factorial is 1 into 2, right? Again it is checking I lesser than or equal to 3. Yes, because I is only 2 now, n is 3. So again what is happening? It will come here. So again I is 3. So fact 2 into 3, 6. Again it is coming here. I lesser than or equal to 3. Yes. 3 lesser than or equal to 3. Yes. What is happening? If it false, because it lesser than or equal to, it is equal to no, then it will come to the false stage. It is printing here. So you can see the flow line here down, again down. After printing, it is going to the connecting here, left arrow, flow line left arrow, then come to stop. So from start it is coming to end. After certain operations, it is coming to the end point along with the print statement. Okay, after the print it is going to the end point. So this is looping operations, right? So you understood the basic concepts of algorithm and how to draw the flowchart from algorithm. That also very clear. So more details you can refer so many textbooks related to the topic. So I have referred this to mainly I have referred these two areas for reference. Thanks to them. Thank you and have a nice day.